right, welcome back. Today is the last section of chapter 11 based on area. And today we're taking a focus at similar figures. And if you remember what similar figures are from before, it's figures that have the same shape, but they have different sides. So for example, a square, same shape but different sides. And we're looking at how does that relate to area today. Again, I'm going to leave these warm-ups for you as extra practice. If you'd like to check your answers on Haiku, you can do so. So similar figures, like we just mentioned, have the same shape, but different sides. Remember, the sides are proportional. We talked about that earlier in the semester, earlier in the year. So like squares would be similar figures. Circles are always similar. A scale factor, we use the letter K to represent. It is simply a ratio, which is a fraction of the corresponding side lengths. I'll show you an example of that in a minute. All right, so let's take a look at these two rectangles we have drawn over here. Let's say this side is 5 and this side is 2. Our scale factor then would be the image over the pre-image. And let's say we're going from here to there. So our image is going to be what we end up with, the 2. The pre-image is going to be what we started with, which is the 5. So our scale factor is 2 to 5. And we should know that because 2 divided by 5 is going to be between 0 and 1. And our shape is getting smaller. It's a reduction. Now what if the area of this one was 32? How can we find the area of this one? This is where the area ratio comes into play. If we have two polygons that are similar, then their areas are proportional to the scale factor squared. So what we're going to do to find the areas, we're going to set up a proportion to help us solve. We're going to start with our scale factor. So we know our scale factor is 2 over 5. But because we're talking about area, we are going to square it. So 2 squared is 4 and 5 squared is 25. Now using that, we're going to set up a proportion to help us find the area of this second shape. So there's a couple of ways we could write this formula, but let's start with the proportion. Let's start with the 4 over 25. And because we're going from the 4 to the 25, we're looking for the area of this shape, the second one, the green one, and let's just use that as x over the area of this one. We have to be consistent. So we have the smaller rectangle on the top, the larger rectangle on the bottom. X is representing the area of this green one right here. So let's go ahead and cross multiply. So 25x equals 4 times 32. Divide each side by 25, and you should get x to be about 5.12 units squared. So the area of that second rectangle, this one right here, is 5.12 units squared. So we can use the scale factor and the area of one figure to help us find the area of the other figure. So we have these two similar rectangles. The area of ABCD, so I'm just going to label it. The area of this one is 48 inches squared. We don't know what the area of this one is, so let's just use A for the area there. Find the area of PQRS. So we'll notice this is 6 inches and the area is 48. What is the other side going to be? You can think of it, we know area equals length times width. So if our width is 6, what's the length going to be? Well, it has to be 8 because 6 times 8 is going to be 48. So we know this is 8 inches. So what would our scale factor be then? If we look here, I just want to double check. BD corresponds with QS. So BD is right here. BD corresponds with QS. So we know those are corresponding sides, even though it doesn't quite look like it. It looks like the rectangles might be turned. But according to our similarity statement, this 8 does correspond with the 9. So our scale factor is going to be 9 over 8. Again, our figure is getting larger, so we want to make sure that our scale factor is greater than 1. If we're talking about area, we have to take our scale factor and square it. That's the key that some of us forget. We have to take the 9 and square it to get 81. We have to take the 8 and square it to get 64. So this is going to help us find the areas. So start with our scale factor squared, 81 over 64, and we're going to set up a proportion. The 81 corresponds with this one, so we're going to put area on top, and then the area of the other one on the bottom, because the 64, the one on the bottom, corresponds with that A, B, C, D. And then we're simply going to cross multiply. 64A equals 81 times 48. Divide, we should get our area to be 60.75 inches squared. Okay. With a rectangle, there are some other ways to do it, but I'm going to try to stick with focusing on this area ratio to help figure it out, especially as we get into different shapes. Number 2, the area of triangle ABCD. So the area of this triangle is 98 inches squared. The area of this one is 50 inches squared. So now they're giving us the areas. The two triangles are similar. Find the scale factor from ABCD to RTS. So they're giving us the areas. Let's start with what our scale factor is right now. Our scale factor, and they want scale factor from ABC to RST. So let's go 14 over X. We're given areas, so we want to take our scale factor and square it because we're talking about areas. So we want 14 squared over X squared. So our scale factor squared is going to be 196 over X squared. Now what we can do is we can use this to help us set up a proportion because we have areas. We know that this right here in green that I just wrote is the scale factor or the ratio of the areas. So we're going from here, the 98, to the 50. So let's put 98 over 50. Those are areas. And then we're simply cross multiplying. So 98x squared equals 196 times 50. We need to divide each side by 98, so go ahead and multiply and then divide. We should get x squared to be 100, which is nice because when we take the square root of it, x then is 10. So remember, the question asks us to find the value of x, we just did that, and then to find the scale factor. So the scale factor we had here, but we need to substitute in for x. So 14 over 10, and we want to reduce that, divide by 2, divide by 2. Our scale factor is going to be 7 to 5. Okay. Let's take a look at one more example. The area of one side of a skyscraper is 90,000 square feet. So let's think of what a skyscraper looks like. The side of one. The side of one is going to be rectangular shaped. So let's draw one skyscraper. The area they tell us is 90,000 feet squared. The area of the corresponding side of a scale model, so a much smaller one, when they were in the planning phases of it, the area of that one is just 200 square inches. If the skyscraper is 720 feet, so let's label that 720 feet tall, how tall is the model? So we're figuring out that. Now notice this one is all measured in feet, which means this one is going to be all measured in inches. We do not need to convert. We just know that when we figure out what this answer is, it's going to be in inches. So let's start with our scale factor. Our scale factor, it doesn't really matter, just be consistent. If we go from 720 to x, then we need to make sure we go from the 90,000 to the 200. So let's go with 720 over x. Because we're talking about areas, we need to take our scale factor and square it. So 720 squared over x squared. 720 squared is going to be a pretty large number, 518,400 over x squared. Now we're going to use that to set up a proportion with the areas. So there's our scale factor squared. We went from here to here, so we have to go 90,000 on top and 200 in the bottom. And we're going to cross multiply. Now we're going to get some pretty big numbers here. Let me grab, let's see, we can reduce this by a couple of zeros there. That's pretty good. Now it makes the numbers a little bit smaller. 900x squared equals 2 times that 518,400. Run out of space there. Divide each side by 900. X squared is 1,152. And opposite of squaring is square rooting. So we should get x to be about 33.9 inches. So that model, that height should be about 33.9 inches. Okay? Take a look at your assignment below. Again, find scale factors, and then if you're talking about area, don't forget to square them. Check with your teacher about which review days you're going to be doing. I know I am only going to do one of the days, but again, look to the haiku page or an email to find more details. All right, that's it for chapter 11. Next chapter is volume.